Hi, my name is Becca Thompson, and I am here with a PSA to talk about division. We could think about dividing our country into factions of who believes that the coronavirus was preventable, who believes that it was inevitable. Or we can talk about it just from a purely numeric standpoint. So, what does it mean? What is division? While you ponder, I'm going to tell you this much. In counting, division is the undoing of multiplication. But it's a very specific undoing. Everything has to do with equal. So we talk about this a lot. Division is usually represented at the beginning to children of if I have this thing and I give it equally to each of you, what is it? Right? So let's do a super fast thought question. Okay? Let's say I have 5 children in a room, and I say, oh, let's say that I have 5 children and I have 10 cookies. And I present to the children, how many cookies does each of you get evenly? And we would say 1, 2, 3, 4, 5, and then we start counting over again, right? 1, 2, 3, 4, 5. So 2 gets those, and 3 gets those, and 4 gets those, and 5 gets those, and 1 gets those. And they each got how many? 2, right? And the symbol we use would be this. A great exercise for division, if you want to talk about counting in whole numbers, I'm just going to tell you this right now. I don't have it with me. I'll try to do a side lesson on it. Is take Skittles are great because they have just enough candy coating on them that they don't get sticky. M&Ms get sticky if you play with them too much. Starburst are great too because they're in wrappers. They're great. Like a big bag of Starburst. And you use them, you can batch them up in colors, you can batch them up, you can just divide numbers. And it's great with children because you can pour out like, say 18 Skittles, right? And you say, okay, how can you make these piles even? And little children will just, they'll realize, right? They won't even necessarily know at first. And then you'll say, okay, how many is in each pile? And you'll have either 3 piles of 6 or 6 piles of 3, or you'll have 9 piles of 2 or 2 piles of 9, right? Kids they just get this, right? And those are the factors, that's a word we use, factors of division. So let's go back though to division. Division is a big idea. It really is. Because multiplication is one way. The same way we did the number line, right? If you add, you go forward. If you subtract, you go back. If you add, you're giving. If you subtract, you're taking, right? Multiplication is you just do it. Go forward, right? But to go back in evenly can be looked at in a lot of different ways. So you can think of it this way, okay? I'm going to give you some hot spots thinking about division. Where's my awesome twins cap? I'm going to use as my eraser right now. I can just throw this in the wash, okay? Don't freak out. Okay. So if you did a multiplication table, okay, 1, 2, 3, 4, 5, 6, blah, 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 1, 2, 3, 4, 5, 6, right? And you do all this and you have all the crisscrosses and you have it all filled out, right? At some point, right, you're going to have 3 4 is 12, and 2 6 is 12, right? You should fill this out when you do it, just counting. But when you divide and you're looking for whole numbers, to start division, you would want to say 12 divided by 4 is 3, right? But 12 divided by 6 is 2. Well, what's 12 divided by 7? Now we have to kind of mentally think about our cookies again. We have 12 cookies and 7 children. How is that even? And that's where we get fractions, right? And most of us learned fractions from the idea of pi, and not this pi. Okay? Not the math pi, but the actual pi. I sometimes try to use slices of pizza as an idea. Because it's the very first and most rudimentary fractional thing that children are exposed to. But division itself is very complicated. And you might notice from my lessons that I teach upper level mathematics. So I have elementary lessons that I've done with kids, but it doesn't necessarily mean that that's my end game goal. I want us to always be looking at deeper, 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 right? So let's wipe this off. Fancy time. I'm at 6 minutes, so maybe I can get one more and then I'll do examples. So, simply put, this symbol, 5 times 3, means I add 5 to itself 3 times, right? 5 plus 5 plus 5 is 15. This symbol is the opposite, okay? And what this actually means, these dots and the line imply a fraction. Because this can also be written this way, right? Which 15 divided by 3 is, we just did it, 5. These symbols are all the same. Fractions are implicitly an operation. They are division, yet we can sometimes let them stand alone when we want to. Like, for example, 2/3, we all kind of get as 2 parts out of 3. But this is also an implicit operation, 2 divided by 3, which is 0.6 repeating, which we usually know from the calculator. And there's an awesome way to convert from decimals to fractions, which might be our next lesson. But so, for now, it's best to think about division 2 ways. You can either think of it as the 2 prongs of your multiplication table, where you have, because we're going to be looking for whole number divisions, or you can think about cutting up cookies or pies to children or yourselves. I'm not going to lie, division is the most complicated aspect of what we do in math, because division yields fractions and it yields decimals, and the symbology is a little weird. But so I think next up we're going to have, the easiest to think of it right now is that it's an undoing of multiplication, though. Because if we think that multiplication grows, division is just, you're just going backwards, and the root can be anything, right? The root can be a fraction. The root can be something that's a decimal. And that's why we get a lot of those. And then we build out that way. And maybe we have a fractional multiplication, and that's also something going on. All math is counting. So, the next thing, shoot, I'm at 9 minutes. The next thing, we're going to do some examples of order of operation with division, but I think we're just going to do some division first, okay? Long division. It's important, you guys. And calculator, no calculator. No. There is 0 point to try to actually learn math with a calculator. That's like Google searching a poem when the whole point is you to learn the poem. You learn the poem, right? That's like watching video of somebody winning the Boston Marathon, but it's like, but you need to run it. I know someone else can win it. That's not the point. The point is, can you go out and run this distance? Can you get yourself to do that? So a calculator is just like watching someone else do it. It's useless until you understand what's going on. And then usually, if someone has pushed themselves in a marathon, when they watch it on TV and watch like international level competitors, you go, wow, yeah, that is hard, because you have an appreciation for it. But if that's all you do, you never get an appreciation because you don't realize that you can do it too. Okay? All right. Stay safe. Happy division. I'm going to go finally eat my breakfast. Life in the digital world. All right. See ya.